Unit 4, what we're talking about, triangles, different triangles. We're going to talk about for these next 2 days some different triangle relationships. So we've got a packet, and we're going to fill it in and practice some different triangle relationships. These are some triangle relationships that we'll probably see on ACT tests, benchmark tests, state tests, all that kinds of stuff. So just some good little relationships between triangles. And today we're going to be focusing on something called a mid-segment of a triangle. Mid-segment. Now, the word mid-segment kind of says what it is, right? Obviously, it's a segment, and mid probably means it's where? In the middle. Now, when I say in the middle, it's actually connecting two midpoints. Okay? It connects two midpoints. So the segment is exactly in the middle. So this point D right here is halfway between points A and B. It's the midpoint of that segment. Okay? And this point E over here is the midpoint of, I can't see it all, B and C. And I have y'all froze. No wonder. Okay? So it is the midpoint of B and C. So that's what those little tick marks that match up are saying. That does not mean that this side's congruent to this side. It means that this side's congruent to this side. Does that make sense? So the same amount of tick marks are congruent to each other. So a mid-segment of a triangle is a segment connecting the midpoints, first blank, midpoints of the two blanks of the triangle, of the two sides of the triangle. For example, DE is the mid-segment of this triangle. Because D is the midpoint of AB, E is the midpoint of BC, so DE is the mid-segment of the triangle. Okay? It's the segment in a triangle that connects to endpoint or two midpoints of opposite sides. All right, so this creates some really good relationships in a triangle. So this is the triangle mid-segments theorem. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side, and it's half as long as the third side. So DE is going to be, since it's the midpoints from AB and BC connected, it's going to be half as long as segment AC, and it's also going to be parallel to AC. Okay? It's parallel to the third segment and half as long as the third segment. So in this diagram above, since DE is a mid-segment of triangle ABC, then segment DE is parallel to which segment? AC. Very good. And the length of DE is a half of the length of segment AC. Is there another way I can write this equation? Instead of saying DE is half as long as AC, what else could I say? Yes. Or I can see 2 times DE equals the length of AC. Right? Right? So I could use that both ways. Because if I wanted to get rid of this fraction, I would multiply both sides by 2, and I would get this equation. Right? So I can double the mid-segment to get the bottom segment, or I can half the mid-segment to get the long segment. Right? So either one of those equations will work. All right, number 1. All it wants us to do on number 1 is identify all pairs of parallel segments. Well, look at that. How many mid-segments are in this triangle? There's 3. Because look, this is the mid. Y is the midpoint of RS. W is the midpoint of QS. X is the midpoint of QR. And I get that because of the tick marks. Y'all see that? These 2 are congruent, these 2 are congruent, and these 2 are congruent. Y'all see that? We'll zoom a little bit so I can see better. That's a little better. Okay? So all of those points in the middle of the segments are midpoints. So that means all three of those segments are mid segments. So I'm just going to start with one. Segment WY right here is parallel to what segment? QR. Y'all see that? It's the one that its points are not touching. So WY is parallel to QR. All right. Let's do another one. XY is parallel to what? QS. And which other one I haven't done yet? XW, very good, is parallel to RS. Y'all see how we identified all of those sides? Y'all try number 2. Set each mid-segment parallel to the segment that it's parallel to. Any questions on these? And you can go in any order, as long as you do all 3 pairs. Number 3. Find the dimensions of the rectangle below if the area is 128 square feet. All right. So very similar, but we don't have a monomial times a binomial this time. So y'all told me the area is length times width. What am I plugging in for A? 128. So this time I have a binomial times a binomial, and remember order doesn't matter because multiplication is commutative, but parentheses do have to be there. Parentheses are not optional. How do we multiply binomial times a binomial? Well, look at times X. X times 7. Negative 1 times X. Negative 1 times 7. All right, combine my terms. 128 with X squared plus 6 times 7. All right, so I'll just start with one. JK is parallel to what segment? I should put segments over it. Over FH. Okay. KL is parallel to what? GF. And again, you could have done these in a different order. And then what's my last big segment? JL. JL is parallel to what? GH. Did y'all get those pairs? Any questions? All right. Like I said, the order could have been swapped around. All right. So number 3 is a little bit different. On number 3, they give me the lengths of these segments, right? And we have to find some missing lengths. So I'm going to go ahead and write in all of the ones they tell me. So they tell me PR, which is this whole segment, is 40. Nope, I lied. It's 46. Sorry. PQ, which is right here, is 40. Jeez, come back. LN, which is this little one right here, is 17. Find each measure. Okay, so remember, if we are looking for a mid-segment, we have the long segment that it correlates with. And if we're finding the outside segment, then we double the mid-segment, correct? Okay, so LM. LM is this next segment right here. Now, which segment corresponds with LM? PR, which is 46. So how do I get the mid-segment? 46. 46 divided by 2, or 46 times a half, right? Which is what? 23. So LM is 23. Very good. All right, next is MN. MN is this mid-segment right here. Well, it's the mid-segment that correlates with PQ, right? So how do I get the mid-segment if PQ is 40? Yep, half of 40 is 20. Everybody okay with that? Next is QR. QR is this whole big segment over here. So it's an outside segment. And 17 is the mid segment that corresponds with it. So what do I do with 17 to get QR? Double it. 17 times 2 is what? 34. So if you're looking for an outside segment, you double the mid segment. If you're looking for a mid segment, you half the outside. Y'all see that? Next, they want me to find MR, which is this little segment over here. How would you find MR? Yeah, we said this whole thing was 34, right? And so it's going to be half of 34, which is what? 17. Does that look familiar with something? It equals its mid-segment, didn't it? Right? Because they're both half of QR. Y'all see that? Does that make sense? Yeah. So if dividing by 2 hurts your brain, then you should know it's the same thing as its mid-segment, right? Okay, good job. Number 4, similar problem. First thing I'm going to do on number 4 is fill in the measures that they tell me. So it tells me that they're all midpoints. It tells me FG is 9. I'm trying to write it. GH is 7. And CD, that whole thing, is 24. So what is the measure of segment CE, which is this bottom segment right here? Yeah, you double the mid segment, which is 7. So 7 times 2 is 14. Is everybody okay? Jeez, I keep touching everything. Everybody okay with that one? All right, DE is this whole side right here. So what's the mid segment that goes with that one? 9. So I double 9 and get what? 18. Everybody with me? And then FH is the mid segment right here that goes with CD. So how do I get from the outside to a mid segment? Divide by 2. Divide it by 2 or half it and get what? 12. 12. Stop it. Okay. So D wants me to find the perimeter of triangle CDE. Is that the outside triangle or is that the inside triangle? Inside. Now they could have asked me about a lot of perimeters of a lot of triangles, couldn't they? I said inside. I meant outside. I heard outside anyway. All right. So, but look though. So make sure you read your vertices on your triangle because they could have asked me for this perimeter, couldn't they? Or this one, or this one, or this one, right? Yes. They could have asked me for a lot of perimeters in there. So read your outside vertices. So CE we said was 14. DE is 18. So you're going to add 24 plus 14 plus 18. And what do we get when we do that? 56. 56. Very good. But do y'all see how they could have asked me this one? Mm-hmm. How would I do that? Well, that would be 12 and that would be 9, wouldn't it? Yeah. Right? And we can do that. Very good. Good job. All right, now we get to do some algebra on number 5. Okay. Find the value of x. Well, this length right here, 7x, is a mid-segment, isn't it? Mm-hmm. How do I know it's a mid-segment? Because, yeah, these are congruent sides and these are congruent. Right? Yeah. So that tells me it's going through the midpoints. All right. So how can I set up an equation? 7x is equal to 17x minus 18.
7x times 2.
Yeah, if I double the mid segment, I can set it equal to the outside segment, right? Or you can say 1/2 of the outside segment equals inside. But I don't know about y'all, but multiplying times 2 is a little bit better than multiplying times 1/2, right? Some people are afraid of fractions. So I'm going to do 2 times the mid segment. So 2 times 7x equals 17x minus 18. And set up my equation that way to solve for x, right? Double the mid segment to get the outside segment. So then we're just going to work it out. What's 2 times 7x? 14x equals 17x minus 18. I'm going to subtract 17x, bless you, again. And 14x minus 17x is, my negative disappeared, equals negative 18. Divide by negative 3. And x equals 6. Now, they didn't ask me to find the actual segments, but could we? Yeah. So any questions about that?
Number 6. How would I set up number 6?
You multiply the mid segment by 2 until you get to the outside.
Yes. You multiply the mid-segment by 2. So 2 times 6x plus 31 equals 19x minus 36. And we'll distribute that and then solve for x. So 2 times the mid-segment equals the outside segment. So what's 2 times 6x? What's 2 times 31? Okay, I'm going to subtract 12x to get my x's together. So 62 equals 7x minus 36. Then I add 36 on both sides. What's 62 plus 36? 98 equals 7x. Divide by 7, and what do we get? Exactly 14. And again, that one just asked for x, so I'm done. Not terrible, is it? Actually, it's pretty easy. We've done a lot harder stuff than that, right? Okay. Okay, so on number 7, what's different? Yes, on number 7, you actually have to go and find the length of a segment after you find x, right? So how do you think we're going to set up number 7? Right, double the mid-segment to get the outside segment. So it's 2 times the quantity 4x plus 1 equals 11x minus 25. Any question on the setup? All right, then we solve the equation. 2 times 4x is 8x plus 2 times 1 is 2. And then I'm going to subtract 8x to get my x's together. 2 equals 3x minus 25. Add 25 on both sides. I get 27 equals 3x. Divide by 3 and x equals 9. Do I stop there? No, they want me to find the length of DE. Now, how do I find the length of DE? Yeah, I plug it into 4x plus 1, and now we know 9 is x, so 4 times 9 plus 1, which is 36 plus 1, which is 37. Any questions about that? Y'all try number 8 on your own.
So now we're going to write 2 by 9 factors because the leading function is 1, so 0 equals the quantity x plus 7 the quantity x minus 12. And now we've got 2 equations, x plus 7 equals 0, and x minus 12 equals 0. What's the solution to the first equation? X equals negative 7. What's the solution to the second equation? Positive 12. Negative 7 will not work because negative 7 plus 3 is going to be negative 4, and we can't have a negative 4 dimension. Okay? Now, all this problem says is to find the value of x, or in this case, x is 12 inches. Raise your hand if you got number 4 for that. Very good. Very good. So those of you that didn't, you see where you made a mistake and how to fix it from here on. The other thing is about that.
All right, you're finding the length of RT after you finish finding x. Okay, so how do we set up our equation? 2 times
15x minus 17
equals,
23x minus 6.
what's 2 times 15x?
30x
30x. What's 2 times negative 17?
negative 34.
And I'm going to get my x's together. What's 30 minus 23?
7x.
So 7x minus 34 equals negative 6. Then I do what? Add 34. 7x equals,
20x.
divide by 7, and x equals 4. Did everybody get x equals 4 with their equation? All right, now we want to find the length of RT, which is right there. So RT is going to be 23 times 4 minus 6. What's 23 times 4?
92.
92 minus 6 is what? 86. Raise your hand if you got 86 for RT. I don't know what I was saying. Good job. All right, let's look at number 9. Number 9. I think we can handle it. So, number 9 says, they tell me segment MN, NO, and MO are mid-segments. They tell me that. Find the perimeter of triangle JKL. So my end goal is to know the perimeter of the whole outside triangle JKL. Okay? Well, I already know to do that, I'm going to have to get X, right? So I can't find KL until I get X. I'm going to do that first. How can I set up an equation to get X? Right, I double the mid-segment, 6x minus 1, and set that equal to 13x minus 10. So that's what I'm going to start with. 2 times 6x minus 1 equals 13x minus 10. What's 2 times 6x? 12x. What's 2 times negative 1? And then I subtract 12x and I get negative 2 equals 1x minus 10. I add 10, I get 8 equals x. Y'all agree?
Yes.
My pen's don't want really good. So to get KL, I'm going to say 13 times 8 minus 10. What's 13 times 8? I don't know. I forgot my 13s, I'll be honest.
104.
104 minus 10 is 94. Okay, so I need this whole KL over there. All right. Now I need to know JK and LJ, right? Well, how can I just start? How do I get JK? Yeah, the mid-segment that goes with it is 42. 2 times 42 is what? 84. Y'all okay with that? And then how do I get JL down here?
Double 40.
I double 49. What do I get when we double 49? 98. So for the perimeter, what do? Add all 3 outside sides. So 94 plus 84 plus 98. What do we get? 276. And they didn't tell me any units, did they? So if they had said inches or centimeters, we would have included those. You'll see how we did all that? I found X first because I didn't want to jumble it up with a bunch of numbers until I found X, and then I just found the rest of them. So can we hang with a problem like that? Not terrible. Okay, so the rest of the problems on this section have to do not really with the lengths of the mid-segments and the outside segments, but it's more about angle measures. So we're finding angle measures. Now, what is something that we know about mid-segments that might help us find angle measures?
Yeah, parallel lines.
They are parallel lines, right?
And if they're parallel lines, then for angle measures, we have all kinds of angle relationships that we could use, right? Parallel lines give us alternate interior angles, right? Corresponding angles, consecutive interior angles, right? So if I'm looking like, and also look at here, there's some linear pairs in there. Because isn't this 127 and angle 2 a linear pair?
Yes.
I'll say that. Well, let's go ahead and do that. How do I find the measure of angle 2 then?
180 minus 127.
Yep, 180 minus 127 is how much?
53.
Yeah, I'm gonna zoom up so I can write. So that's 53 degrees. So angle 2 is 53 degrees. Is everybody okay with that? Okay. Now let's just backtrack a little bit. How could I find the measure of angle 1? Is there a relationship between these two angles?
They're corresponding.
Oh, these are corresponding, aren't
What is
they?
it?
Yeah.
Consecutive interior.
But these are consecutive interior, and we learned that was the oddball relationship. What's the relationship between consecutive interior? Are they congruent? They're supplementary, right? Which makes sense because angle 1 and angle 2 were corresponding, so they should be congruent. And weren't these supplementary as well because they made a linear pair? Yes. Okay. So that's all you're going to do. They're either going to be equal to each other or they're going to be supplementary with each other. Does that make sense? Subtract from 180. So angle 1 is going to be how many degrees then?
53.
53 again. Because it's corresponding with angle 2 and it's a linear pair with 127. Okay. Angle 3, I might have to wait on that a second. So look at angle 5 and angle 4. What's their, 5 and 59 are a linear pair, they're consecutive interior, right? That's their supplementary. And what's 59 and angle 4's relationship? Corresponding, so corresponding are what? Yeah, congruent. So angle 4 is also going to be 59 degrees. And how do I get measure of angle 5?
180 minus 59.
Yep, 180 minus 59, and how much is that?
121.
121 degrees. So angle 5 is 121 degrees. Angle 4 is 59 degrees. So when you're filling in the blanks, make sure you fill them in the right spot. How are we going to find the measure of angle 3?
Add the angle 4 and angle 2.
Yeah, and I actually could have done it with these two angles. I didn't think about it, right?
Yeah.
Yeah, I could have, because that makes a triangle as well. But I'm going to add 53 and 59, subtract from 180 to get angle 3. Does that make sense? Triangle sum theorem. So 53 plus 59 is 112. 180 minus 112 is what?
68.
68 degrees. So basically, they're either supplementary or they're congruent. Just depends on the relationship. Is that okay with everybody? Okay. Use your parallel relationships. Okay. Let's look at 11. I like they didn't give us very much room on number 11. That's okay. All right. I'm just gonna go in order, I think. How can I find the measure of angle 1?
180 minus 3, 118.
Yep, 180 minus 118. Do y'all see that? Those make a linear pair. Also, 118 and angle 5 are consecutive interior, so they're also supplementary, right? And I know 5 and 1 are going to be congruent because they are what?
Corresponding.
Corresponding.
So what is 180 minus 118?
62 degrees.
62 degrees. So angle 1 is 62 degrees and angle 5 is 62 degrees. Y'all agree? 62 degrees, 62 degrees. How can we find the measure of angle 2? Did we already find that? Yep. How do we find the measure of angle 2?
62 and 95.
So 95 plus 62. I cannot count. 95 plus 62. I got that equals 157. And then what do I do?
Subtract it from
180 minus 157 is how much?
123.
So angle 2 is 23 degrees. What other angle is also 23 degrees?
Angle 4.
angle 4, because those are corresponding. And how could I find the measure of angle 3?
Subtract 23 from 1.
Yes, because it's consecutive interior with angle 4, and it's a linear pair with angle 2. So 180 minus 23 is what? 157. Not bad, is it? You okay with that? Okay, good job. Let's look at number 12. On number 12, we have to do algebra again. Okay, so those are mid-set. This is a mid-segment because it's going through the midpoint of these two sides of the triangle. So what, if these are a mid-segment, that means these lines are parallel, correct? These lines are parallel to each other. So I'll put the little arrow showing that they're parallel. So if those are parallel to each other, what's the relationship between these two angles right here?
Corresponding.
And corresponding angles are what?
Congruent.
Congruent. So how do you think I could solve for x? Yep, if they're congruent, set them equal to each other. So 7x plus 4 equals 10x minus 11. Y'all with me? So set them equal to each other because they're corresponding angles, which means they are congruent. So subtract 7x. So 4 equals 3x minus 11. Add 11. 15 equals 3x. Divide by 3 and x equals what? 5. And that's all it said was find x, right? Could I find those angle measures? Easily, right? It's going to be 39, isn't it? 39 degrees? All right, but it just said find x. So look for the angle relationship that you got going on with those parallel lines. If they're congruent, set them equal to each other. What do you think we're going to do if they are supplementary? You add them together and set them equal to 180. So on number 13, that segment is a mid-segment because I have the little tick mark showing congruent lengths. So that means these two sides are parallel to each other. So what kind of angle relationship do I have between these two parallel lines going on?
Consecutive interior.
Consecutive interior. And consecutive interior angles are what with each other? Supplementary. So that means they add together to make 180. So that's how I set up the equation to find x on this one. I say 5x plus 2 plus 11x minus 30 equals 180. Any question on that setup? All right, so combine like terms. What is 5x plus 11x? Good. And positive 2 minus 30 equals 180. And then we'll add 28. So 16x equals 208. And divide by 16 and x equals 13. And they didn't tell me to plug in, it just said find x. So if they're congruent, set them equal to each other and solve for x. If they're supplementary, add them together and set them equal to 180 to solve for x. All right. What would you do on number 14? And then it says they want you to find the angle measure, correct? What would you do on number 15? Add them and set them equal to 180, and then you're finding RTV, which is this angle, right? So any questions about anything we have went over today? So mid-segments are half the length of the outside segment of the triangle, and they are also parallel to that same segment. Got it? All right, that is the end of notes for today. Hope you enjoyed it. If not, too bad.